In this lesson, we are going to take a look at 2.1 Day 2 and how we name angles and then some relationships with angles. So the first part we need to talk about is a ray, because an angle is actually made up of two rays. An array just has an end point. So kind of like the sun's ray has an end point and then it goes on forever in one direction. And it matters how we name this. So notice that the endpoint is A, so we're starting with our little symbol here. The endpoint is closest to the A. The arrow is closest with our C or our B. You could name it ray AB or ray AC. But notice the arrow is with or above the C and the B. Two opposite rays, so a ray going kind of this direction and a ray going that direction, opposite rays form a line and or a straight angle. And that angle measure is 180 degrees. This right here is an angle. It is made up of two rays with a common endpoint that we call a vertex, which we'll talk about more in a second. But we would name this angle by either its vertex point, so angle A. That is not as common just because we might have a couple of different angles in some of our pictures. And if we name it angle A, we wouldn't know, are we talking about this angle? Are we talking about this angle? Are we talking about this angle? So we really only use the vertex to name it if it's the only angle using that vertex letter. The most common way to name them is going to be with our three letters. So coming from out into the vertex and back out. So angle DAB or angle DAC, or we can go the other direction, CAD, but notice that the vertex is always going to be in the middle. So the sides of our angle are rays. There's one ray, there's the other ray. And so again, we want to label it with our end point and then the arrow, making sure it's closest to the other letter. And then our vertex is always at the center there. It's the common end point. So we're going to go ahead and practice naming some points. This would be the interior. This would be our angle, if I could actually draw it on it. There we go. And then this would be the exterior. So on the angle here would be points D, A, B, and C. They're on our angle. In the interior would be points G, F, and H. And then the exterior is going to be I, J, and K. Down here, we're going to name the vertex of angle 4. So I'm just going to kind of highlight angle 4 so that you can see it. And you could go all the way. So it's this angle right here. So we can go ahead and name this angle 4. Or this angle 4, we can name its vertex here at this point U. So U is its vertex. And then this next one, we're going to name the sides of angle 3. So here's angle 3. So we have this ray, and then we have this ray that form that angle 3. So XW, and I want to make sure that my arrow goes near the W, and then XU, and there is the two sides of my angle 3. Another way to name X, Y, U. So go X and then N to Y and then out to U. Now, this could be angle 2. And this could also be U, Y, X, kind of going the other direction. Make sure that you have your angle symbol in front, since that's what we're naming. It could not be angle Y because we don't know, well, are we talking about this angle or angle 2? And these I know don't really have any other letters, but we could also maybe be even talking about either one of those if we used just the vertex point Y. It's being shared. So we probably don't want to use just that vertex. Okay, I'd like for you to try example 2 here. You're going to figure out which of these names, there's more than one, would be a legitimate name for DB as a side and DC as the other side. So how could we name this angle right here that I just highlighted in red? So circle all that apply and check when you're ready. So you could have named it angle 2 because right there is a 2 inside of that angle. You cannot name it 3 because that's this angle down here and that's not it. ADB, ADB, so this angle right here, angle 1, nope. And then BDC, yep, BDC. And then going the other way, CDB, yep. And then E we don't have, let's pretend E was here. So if we did EDC, that would be this angle next to it. So nope, just AD and E. So these last two examples go very similarly with what we did with segments. We have two types. We have one that is being bisected where we're given the left and we're given the right. So we would just set them equal and solve. The other type you might see is if we again kind of have it being bisected. We have the left, we have the right. Well, we have one, then we know the other, and then we have the total. And whenever we have the total, we can go ahead and add that left and that right angle and set it equal to our total. Again, very similar to what we did with segments. So for this one, we know that this is opposite this, which means it's a straight line, which in the future will help us, doesn't necessarily help us that much on this one. But this right here, BD, that ray, bisects this angle ABE. So that means that it's going to cut it into two congruent angles, which is why I put an arc mark here and an arc mark there to represent that this and this are equal or the same. So then we want to label, if it wasn't already labeled for you, A, B, D, and putting that in there, and D, B, E, putting the 8x minus 32 there. So we don't have a total, but we know the left and the right are the same, so we set them equal. So we're going to go ahead and put our 4x plus 14 equal to 8x minus 32 and solve. 14 is equal to a 4x minus 32, and then we solve by adding 32 to both sides. And we are going to get a decimal when we divide by 4, but it's not too bad. It's 11.5, which is going to help us now to answer what they want, which in this case is to find the measure M. Right here in front of our angle stands for measure, meaning the actual value, number, degrees for angle DBE. So DBE is right here. So 8 times 11.5 minus 32. And that is going to give me 92 minus 32, or 60 degrees for the measure of angle DBE. Last one. Again, we have opposite rays, so it's forming a straight line, so 180 degrees for all three of those angles together, but we really don't need that one at this time. KN, it's bisecting this angle LKM, so that again means tick marks here and here. These are congruent, and I know LKM, the total, is 7x minus 5, and I know that NKM, this angle over here on the left, is 3x plus 9. Well, my arc marks tell me that this angle and this angle are the same. So if this is 3x plus 9, then this has to be 3x plus 9. And now I can go ahead and do my left plus right equals my total, which I have all three of those pieces. So I'm going to add my 3x plus 9 and my 3x plus 9, and I'm going to set it equal to the total. So 3x plus 9 plus 3x plus 9, you can do it vertically, you can write it out horizontally, however you kind of want to do it. And that is a 6x plus 18. And then we're going to solve. Let's actually subtract our 6x first. That's going to be a little bit easier. Get those x's together. And add 5. There we go. X is 23, but we don't just want x. We want the measure of LKM, which is the total. And so LKM, we're just going to use our 7 times 23 minus 5. So replacing the x with our 23 is going to give us 156 degrees. Make sure that when we're talking about the measure that we put our degree symbol in there because angles do have degrees.